50. So please, thank you. So please keep this in mind, that this area is base times height. Okay. Now, look carefully what happens here. And you can say, what am I looking at? So I'm going to look at this area in green. And as you see, it's attached to the demand function. And this area in green is called consumer surplus. I'll explain what it means in a moment, but can anyone have an idea on how to calculate it? How to calculate this area? This is not a rectangle. This was very easy, base times height, but this is not a rectangle, and I want to determine it because this area will have a dollar sign to it. It will be something, whatever, I don't know, $5, $3, 35 cents, I don't know, but it's gonna have a dollar sign to it, this area, and it will be called consumer surplus. And I'll explain what consumer surplus means, but first, how do I determine the green area? Based on what we discussed in chapter 4. Think about what we discussed in chapter 4 and have an idea on how to determine that area. Just the green one. Yes, I'm ready.
How we did is that how we did above and below? Like from the left and from the right side?
So here's a hint. Is there any way of determining this area and then subtracting from it this area to determine the green area? Consumer surplus. How do I determine this area?
Would be integral from 0 to 10.
Very good. From 0 to this value, in this case is 10 because we picked 10. Awesome. From the demand function dx, but this is the entire area. What do I have to subtract to get the green area alone?
The area?
The 50. Very good. Exactly. So this will, once we calculate this, we will get some amount in US dollars called consumer surplus. Okay, now let's write and see and just explain in words what the consumer surplus is. So consumer surplus. Consumer surplus is some added value. So to a purchase. So in other words, we are paying $5 per unit, but actually we should have paid a little bit more. Okay? So what is the extra? The surplus. The surplus that we are getting, it's an added value to a purchase. So we're paying $5 per unit, but we should probably pay a little bit more than $5. It's worth more than $5, but we're happy that we pay $5. But that's the idea of the consumer surplus, a value, an added value to our purchase. Okay, so I'm coming back to analyze. We analyze the equilibrium point, but it doesn't matter, right? So if we are looking at any demand function, let's say d of x, at any point, let's say here, let's say we have for x, which is the number of units, 15, and let's say the price is 2. So if I buy 15 units, the price per unit is $2. So dollars per unit, and this is units. I'm not going to buy 15 cars only because I'm going to get them each for $2,000. I'm not saying that. I'm just saying that if we buy 15 units of a particular product, we will pay $2 per unit. This piece is a value or an additional utility, if you want. We are getting a little bit more because the price should be a little bit higher, but it isn't. So this area is the consumer surplus. If d of x, let's say it's x minus 4 squared, and all this is given to us, 15 units at $2 per unit. Can anyone dictate how we determine the consumer surplus? Which is just this area.
Is it going to be integral from 15, no, from 0 to 15? And then d of x, so it's x. And then our area.
Yes.
So it's 15 times 2.
That's it. That's how we determine the consumer surplus. For any point, including the equilibrium point, it's the same procedure. Everything is the same. I just wanted to remind you that we discussed the equilibrium point, demand and supply. It's a point where the two functions meet. So it's the same x and the same y, of course. But it doesn't matter. So since I made up this example, let's continue and let's find out what this is. Okay? So we can expand this or use a substitution. Which way do you want to go? I'm hoping you're going to say use a substitution because we discussed that in 4.5. So what will be the substitution then?
X minus 4.
What will be du, without which I cannot continue?
1.
Du is made of two parts. Du is not the derivative of the function.
dx.
Dx. So it's 1 dx. Perfect. So now can anyone give us this? Do not copy the limits of integration. Please remember. When x is 0, what do I write?
Negative 4.
Perfect. When x is 15, what do I write?
11.
Perfect. So then what is this piece? What do I replace this piece by?
U squared.
Good. What do I replace this by?
Du.
Awesome. And this is minus 30. So this is u to the third over 3 from negative 4 to 11 minus 30. I do not go back. It's a definite integral. So I have 11 to the third over 3 plus, because it's minus, but it's negative 4 to the third power. So 64 over 3, but minus 30. I made the problem on the spot, so I'm just gonna, I don't know what I'm going, I don't know what to expect. So plus 64, and divide the whole thing by 3, and then minus 30, so 435. So that is the extra that we are getting if we purchase 15 units at the price of 2. And this is the area. This piece is $435. So this is the additional value that we enjoy without paying for it. Okay? In the same way, let's discuss now the producer surplus. So this is the supply function. Any point, doesn't matter where. So let's say this is, I'm making numbers up. Let's say we want 5 units at the price of 6. Now, see what happens. In the area of 5 times 6, we have this area that is the producer surplus. Can anyone have an idea? How do we determine the producer surplus? Here's a hint. Can I determine this area? How do I determine this area based on chapter 4? Anyone would like to give it a try?
What do you guys do, like the total area minus the
Yes,
integral of the function?
yes, the total area, 5 times 6, but this time minus this area to determine the blue area. Excellent, thank you. 0 to 5 from S of x dx. Exactly. So notice the difference. For the consumer surplus, we have the total area minus the rectangle. But for producer surplus, we have the total area minus the area under the supply function. Okay? So if I make up, I made up some numbers. Let me make up the supply function. Let's determine this. So this is 30 minus the integral from 0 to 5 from x squared dx. Let's see what we get. And we're going to choose problems right now. So we have 30 minus x to the third over 3 from 0 to 5. So I have 30. When I plug in 0, I'll get 0, so I only plug in 5. 30 minus 125 divided by 3. And that's that is going to give us 90 minus 125. So it's going to be a negative surplus. So 90 minus 125 divided by 3. So how much is that? Negative 35, is it? I doubt that that's going to happen because the producers will never lose money. But it was an example, and I just wanted to attach a function to it. Okay, that's how we calculate the consumer and the producer surplus. So let's choose problems. On page, where is it? It's 5.1. It was there, but I lost it. So page 480. Enter. Okay. So, careful, we only discuss, say, consumer equilibrium point, the consumer surplus and producer surplus. We are not discussing the other, the deadweight loss, and these are specific to economics. If you embark on that path, you're going to learn these. So here we only discuss the equilibrium point and the consumer surplus and producer surplus. We can choose any problem. Okay, so let's look at the 26. So let's look at the equilibrium point, the consumer surplus and producer surplus at the equilibrium point. So all we need to do is copy those two functions. So 26, and this is on page 480. And we have the demand function, 5 minus 0.06x, and the supply function 1.5 by 0.03x. X is in gallons. Please remember the measurement unit. And dollars per gallon. Price per unit. Good. So first of all, they're asking us to find the equilibrium point. How do I find the equilibrium point? How did we find the equilibrium point before? Anyone?
Do we set D and S equal to each other?
Very good. So d of x equals s of x. So 5 minus 0.06x equals 1.5 plus 0.03x. I move 1.5 to this side, subtracting it, right? So I get 3.5. I move 0.06 to this side, and I'm adding it. So 0.09x. Let's look again for 1 second. It was 5 minus 0.06, yeah, that's correct. And 1.5 minus 1.5 plus 0.03, yeah, I just wanted to make sure. Okay, so that's fine. So then x equals 3.5 divided by 0.09. For such a calculation, I don't need 3.5 divided by 0.09. I got 39. Approximately 39. Good. So then the equilibrium point has two coordinates. X is 39, comma, and I have to determine when x is 39, both of them have to be the same, right? It's going to be a minor difference because I approximated it. So 5 minus 0.06 times 39. And 1.5, they have to be the same. I just want to see for 1 second. That was plus here. 2.67, 2.66. I'm okay. So 2.7. So 39 units at the price per unit of 2.7. Okay. So in step number 2, they're asking us to find the consumer surplus. What does the consumer surplus equal to? How do we write it? What is the formula?
It's prime of
0
integral of 0 to 39 and then dx minus our area.
Yes, 5 minus 0.06x dx minus this product. So 39 times 2.7. I got 105.3. Perfect. So I have then 5x minus 0.06x squared over 2. So I have 0.03x squared. From 0 to 39 minus 105.3. I plug in 39, well, because when I plug in 0, I get 0. So I have 5 times 39 minus 0.03 times 39 squared. And then minus 105.3. So I got 44.07. So when we purchase 39 units at the price of 2.7, we kind of pocket, without actually getting this in our pocket, but we kind of pocket $44.07 if we buy 39 units at 2.7 per unit. Perfect. Now they're asking us in step 3 to find the producer surplus for the equilibrium point. How do I find that? What do I have to write?
it's our area minus our integral.
Yes, 105.3 minus the integral from 0 to 39, but from the other function now, from the supply function. So 1.5 plus 0.03x dx. Good. So 105.3 minus 1.5x plus 0.03x squared over 2 from 0 to 39. So luckily, all I have to do is just plug in 39 because when I plug in 0, I get 0. So I have 105.3. And then I just subtract 1.5. I should put parentheses not to forget. So 1.5 times 39 plus 0.03 times 39 squared and divide by 2. Good. So I got 23.98. So approximately $24. So what does this mean? When the producer is selling us 39 units at $2.7 per unit, they are pocketing $24. In other words, the price should have been a little bit lower. Okay, so that is their surplus. That's all there is to consumer surplus and producer surplus. Let's work on another problem. Maybe we want to work on an abstract one. Anyone would like to choose, or I will?
You could choose, Professor.
Okay, I will choose.